This is only the third time we taught the class, so if you see any problems in it, you need to let me know. So these are just safety rules, basic warnings. Safety glasses must be worn in the vicinity of the manufacturing lines. Everybody got safety glasses? And regular glasses are not safety glasses. Short pants or open-toed shoes or open-toed shoe footwear is not allowed in the classroom lab. Synthetic clothing is not allowed when working on the manufacturing line. But when working with more than 240 volts, we don't have any 240 volts. These were basically what we use in the motor control block. Lockout, tagout rules and procedures must be followed. Do not perform any maintenance while any power source is energized. And it says lockout, tagout. Always verify the lockout, tagout has been achieved by verifying. Oh, I can't say this. That all power sources have been disconnected and all stored power has been drained, right? All power must be removed from the modules while waiting an instructor sign off for help. So that means when you're waiting on help, you need to just turn the power off, right? No eating or dip bottles in the classroom. I think the college policy is no tobacco products inside, right? No beverages are allowed. Even though it's against college policy, we allow y'all to have drinks in here, but not over there, and we don't eat in here, right? Everybody understand that? No chairs are allowed at the manufacturing line except for my wheelchair. It says disability exceptions may be possible. Not following procedure will deduct from your student grade. Experiments will be formed in teams of no more than 3 students. So we'll have to figure this out because I think we have 7 people in the class. We can't have one person work by himself. So what that probably means is we'll have two teams of 2s and 1 team of 3. All entries on all lab forms must be made in pencil. Before starting a lab, obtain a blank lab grade form, 1 form per student. Obtain a team maintenance form when performing troubleshooting labs. So we do have some labs that are not troubleshooting. I think we do. One of the labs we'll do is we'll take the line apart, we'll put it back together, get it aligned, and go back up. That would be the next lab we'll do, and then we figure out how the line works, and then we actually start troubleshooting. Fill out the required information at the top of the respective forms. It should be forms before starting the lab. No more than 1 lab form per member and 1 maintenance form per team. So the way I keep up with your grade is I keep up with it on your lab forms. But when you do maintenance, you do maintenance as a team. As a team, does that make sense? So 1 maintenance form per team when we start doing troubleshooting. But every student does a lab form for every lab. Everybody understand that? And since we've only got 3, we'll have to see how this works. We only have 3 groups. It says when the team needs a lab instructor checkoff, the team leader must write his or her name on the sign-off sheet located at the instructor's table in front of the lab. We're probably not going to use that procedure this semester because we only got 3 groups. But sometimes we get a big class. And, in my experience, you have people that want to dominate your time, and then you have people that won't ask you questions. And then they'll say, well, the instructor never asked me, do I need help? All right. So what we do, a lot of my classes, is you just sign a sheet if you need help. Are we okay? Students must take turns as team leaders. Each team member must document the team leader in the space provided on the lab grade form and on the maintenance form. Team members that are present are responsible for correction and operation of the module. Team members will be rotated during the term. So what we're going to do here is we'll assign you to a team. 1 person will be the team leader. The other person will be, or persons will be the workers. And then we'll rotate that all term long. So sometimes, so that way you'll get everybody gets an opportunity to be in the leader, everybody gets an opportunity to be in technicians, and then hopefully we have enough time where everybody works with everybody in the class. So we'll rotate. Basically what we'll do, the first group, the leader will move, so we'll start off with 3 groups. The leader will move to the next group. The next person becomes leader, right? You understand? So the leader every time will rotate out of the group and go to another group, and that's the way we do it. And then the next person becomes what? The leader, teams will make presentations to other students in the class on the results of both lab assignments. A question and answer session must be included at the end of each presentation. So we have all these whiteboards up here that while you're working, you'll be keeping notes and stuff like that on the whiteboard. Some of the things you actually have to develop on the whiteboard. And then when we get through, we'll do what? Each team will make a presentation to the other team. That make sense? All circuits must be checked for short circuits while the student provides an ohm meter before energizing. If an overcurrent device trips due to not checking the circuit, a 20-point deduction will be made from points. I don't know. I need to come back and look at that. This is real hard to do on ours. It's really easy to do on motor control frames, but it would probably be hard to do on ours because ours have so much stuff on it. But I'll look at that one. The instructor must perform a basic safety check for each troubleshooting lab that requires the part installation or rewiring. So I'll just come over here and look things over to make sure you just didn't screw things up. Once the check is made, the module can be energized and checked for proper operation once your team is confident that the module is working as prescribed. So before you untag it, unlock it and untag it, I want to come over here and look it over. Does that make sense? And then you'll take the locks off. Then you'll verify if you made your correct action was taken to prevent it. And then once the module works, that once you're convinced that the module is working as prescribed, you come and check it out. That makes sense? Then it says in that I've repeated that, by the way. Each team member makes a presentation to the process during. So that's on there. Students will be awarded points for. Students will not be awarded for points for portions of the experiment completed by team members when they are absent or tardy. When the absent or tardy team member returns, he/she must continue labs at the point which the present team members are currently working. There's no time schedule to make up labs due to absences or tardies. Y'all understand that? I mean, if you're absent and we do a lab, your team's going to go ahead and do what? They're going to go ahead. Now we do scale it by 1 lab, which gives you the ability to miss a lab, but you can't come back in and expect your team to go back to where you're at because the teams are going to change anyway, right? Lab grade and maintenance forms are not to leave the classroom. All lab grade and maintenance forms must be turned in to the instructor at the end of each lab session so students' projects can be verified. The lab grade form will be returned to each student at the next lab. We have 2 plastic trays that I put out. One of them says labs ready to be graded. One of them says labs not ready to be graded. So these forms and everything, when you get ready to leave, you need to put them in the not to be graded. This has happened to me before. Well, I've already done that. Well, where's your form? Oh, well, I left that at home. It don't work right in here. So then once you have completed an experiment, staple the lab grade form to the upper. And this is only true with labs that actually has paperwork. Maintenance labs, you'll have a lab form, and I need to reword this too. You'll have a lab form, but then you'll have a maintenance form. You're not gonna, but you'll turn in your lab grade form, and the maintenance form are going to not be stapled together. And why is that? Because the lab grade form is the team, right? Does that make sense? The completed assignment must be turned in while all written questions answered before the beginning of the next class. And that doesn't apply to this class either. I need to go back and really look at this. Questions, completed experiments that require the construction of circuits must be turned in with all. And that doesn't apply to us either. The example of the lab grade, the lab form shown on the next page. So the information that you're supposed to put in is what? Your name, your partner's name, the group leader. You don't have to identify the technician. Then you put the lab number, and then you put the lockout, and then you put the title of the lab. That makes sense. And then at the conclusion of the lab, what do? You fill in the date and the amount of time that you spent on the lab. That makes sense? And then everything else is mine. So this is where I will make deductions from the lab when you start doing different things. Usually I'm fairly lax except for safety when we start out, but after the 4th week I grade strict. Does that make sense? And of course, because you're learning the procedure. Here's an example of the maintenance form that we use. Co-leader, technician 1, technician 2. I'll fill in the information about module number and fault number. And I'll put the date that it was received. And everything else is your responsibility. So you'll be responsible when the job went in work, when it was completed, the time that it's in work, and the total number of man hours. You all understand that? So it took them 6.5 hours. The total number of man hours would be 28.5. Do y'all understand that? How did I come up with 28.5? That's 3 people that worked on it, right? Everybody understand that? I'll also put the description. But what you will do is you will come in and you put the action taken that you did to repair it, right? And then any parts that you have to replace. So we're going to deliberately replace parts. So you're going to simulate that by taking off a good part, and then what will you do? You'll turn around and put that part right back on there. And that's basically R&R, or remove and replace. And then you'll keep up with what you replace, the number, and hopefully we can get the part number. Which students have been supposed to be doing. Normally part numbers are on there. If we can get part numbers, then what we can do, what's nice about the Festo line is they supply all the technical information on that line. So they give you all the specification sheets and everything for every part on that line. Amatrol doesn't do that. So basically right now we have no idea what the part number. If we got the part number and we got the manufacturer, then odds are what we can do, or it's not odds are, there's a high probability that we can get the data sheets on all those parts. And having the technical information on the parts is another tool that we use to decide, when we replace that part. Because a lot of people don't understand that you don't necessarily have to get the part from the people who make it, right? You understand that? All you got to do is make sure that your part that you replace meets or exceeds the part that you're working on. Luckily, we have a lot of standardization organizations out there now, like NEMA, which is the National Manufacturers Association, that sets up physical setups of machines. Which means if I got to replace a motor, I don't necessarily have to necessarily buy it from the company that I have. But it's got to meet not only the electrical specs, but it's got to also meet the mechanical specifications, right? You understand? How it mounts, how long the shafts are, double shaft, and all this other kind of stuff. So when y'all replace a part, then I want y'all to get the part number and the manufacturer number on that. Then the next shows you how I deduct deductions that we do. So when I come over there and do things, this is what I use as the scale of how I'm going to deduct. Are you okay? Everybody okay? Any questions? So that's the lab procedures for the class. Some of them needs to be reworded. When I made this, I copied it over from motor controls. In motor controls, you literally build circuits. This class, we don't build circuits. We just basically, so I'll go back and reword that a little bit. So, got any questions on the lab procedures? Yes or no? So the first lab, I got to go get some more of these. Is we're going to do the lockout tagout lab, which is right here. Let me hand these up. There's two. The bottom stack is the maintenance, is the actual lab grade form. I'll give them one off the top and one off the bottom. And I can't find my rubber bands. We usually use rubber bands on our lockout tag out. And we go through a lot of these. So we basically run them off. Pretty simple, right? We just pull them together. And then, so I punch a hole in it. Usually, the hole has a metal ring around it to prevent, and they're usually laminated too to make them last a lot longer, plastic. So here's our lockout. Some of the tags got on there. Some of the tags over there you'll reuse. And in this class we use pencil. So that means if you get a tag over here that's already been used, what can you do? You can just do what? Erase it. So every lock has a number, and what I want you to do is you can use the same tag. You don't necessarily have to use the same lock. If you look at the locks, they're all numbered and they're in order. And I would like to keep them that way. That way it's real easy for me to see if any of them are missing, right? Does that make sense? So what I want you to do at the end of the class is just take your tag off, and you'll see where they're stuck in the side over there, and just stick them in the side. And then next time you don't even have to use the same lock. Okay, that makes sense. If we do leave locks on during the weekend or after class, then I want the keys to be in there in the slot where the lock goes. That makes sense? Why do I have too many of these? So we're going to lock out. We're going to follow the lockout procedures. Everybody okay there? And then we're going to turn around and do what? Then we'll take them all back off. So it's up to you which, all the Amatrol lines lock out the same. I think we looked at the way, we showed y'all the pneumatic lockout is a little different than the electrical lockout. So it's got those two yellow fingers that pop out. And when you push it back in, you get into your watch. You need to push that thing back in. Everybody okay? Any questions? Okay, all the locks, like I said, I need to go get some wire ties. I'll have to use wire ties on these. I think if we don't have enough, I got some more over there. I think we might have enough. Because we'll need 14. And why is that? Two per person, 2 locks per person, because we have 2 power sources over there. And I'll go in here. I think the lockout tagout kit is in that. I'll like to show you. Yes, I do. But you're supposed to have safety glasses for the class, right? You start bringing them in. Go get my safety